Welcome to the SumoBot tutorial number 4. In this tutorial, I'm going to be showing you how to use SolidWorks to make more complex gear trains than I had in tutorial number 3. In this case, or in the case of tutorial number 3, I showed you a gear train where there was a gear attached directly to a motor that was driving a gear attached directly to a wheel. In this tutorial, I'm going to be showing you how to create an assembly that has a gear train that looks something like this, where it has an intermediate gear stage. So the black gear is driving the blue gear, the blue and yellow are connected together, the yellow is driving the blue gear that's attached to the wheel. The reason that it's going to be helpful and important for us to use SolidWorks to design this gear train is the spacing between this axle and that axle is crucially important. If this axle is moved to the left, let's say about a 1/16 of an inch, these gears will be too far away from each other and the teeth of the gears will literally miss each other. They won't be aligned to touch and the motor won't be able to make the wheels move. If, on the other hand, this axle is moved to the right or placed to the right too close by about 1/16 of an inch, the gears will be touching each other in a way where they are jammed up against each other and they will grind and not really be able to move. So the precise placement and location distance between these two axles is crucial, and that's what I'm going to be showing you how to use SolidWorks and the assembly feature in SolidWorks to do. All right, we're going to go back to our master assembly for our simple SumoBot. I'm going to delete a few of the last steps that we did. So I'm going to, and actually first I'm going to save this as a new file. I'm going to call this master assembly 2 complex sumo. Okay, here we go. I'm going to delete some of the last steps. I'm going to delete the mirror component and the plane that we created. And I'm also going to select this wheel and gear subassembly, and I'm going to delete that from our assembly. There we go. So we're kind of starting over with part of the gear train. Let's go back to Insert Components. We're going to find the gear train subassembly that we created earlier. This is in tutorial number 2. I'm going to place that there. And the first thing we're going to do is mate this gear with that axle. So to do that, we're going to select the inside cylinder. We've done this before. Select the cylinder on that axle. Check mark. Then let's also line this up with the face. So that and that. And I'm going to space them out by about 1/8 of an inch. So it's not quite rubbing, but it's very close. One thing that I did intentionally that you'll see here, you'll notice that this wheel is actually too large to fit where this axle is going to go. And that's something that if there's time at the end of the video, I'll show you how to change. But basically, actually let's change that right now. If we select that part and edit component, we can go back to the original component and change or make changes in it. So that part itself, it's highlighted here. It was called the 2.5-inch wheel. I just click the plus so we can see all the different parts of, or all the different steps that were made. That circle, to make that smaller, I need to change the sketch. Go to, so click plus next to boss extrude. Click the icon for the sketch and then edit sketch. And then you see where it says 2.5 inches there. I'm going to change that to 1.5 inches. How about 1.75 inches instead? Check mark. Exit sketch. I'm done editing the component, and you can see that in our assembly I made changes to that wheel. That wheel is now also changed in its original part file. Okay, so the next thing that I'm going to show you how to do, we've already created one dado cut, and the placement of that dado cut was not very important because we can really just move this motor around to make it mesh with that gear. Kind of in real life, that's how you'll physically do it. The dado cuts, however, are things that once you cut them, you can't move, and so they need to be placed precisely. And so here's how we're going to use SolidWorks to do that. I'm going to first look from the side view, try to be lining things up this way, and that wheel is really going to be in the way of what I'm doing. So I'm going to click on the wheel, then go over to where it is in the Feature Manager design tree, and I'm going to click Hide Components. So it's going to look like it's not there, it's invisible. I can make that come back if I want again. Okay, next, I'm going to mate this gear to the top of this plane. And so here's the idea. The dado cut that we're going to be cutting is going to be on the top of that board. And so we want this circle, there we go, to be lined up with that edge. All right, and it's having trouble with that. Let me do that. Instead of the edge of the circle, let me do the cylinder part of the circle. And I'm going to line it up with the top face. There we go. So it didn't like lining the edges up, but when we line those faces up, we're basically saying that they are going to be, those faces, which are planes, are going to be tangent to each other. And there we go. So as we did that, you'll notice it rotated our gear assembly. Okay, the next thing that we're going to do is we're going to make a dado cut in this piece of wood that's lined up with that circle. So again, I'm going to go back to the side view. I'm going to select the plywood. I'm going to click Edit Component. And then now that I'm in Edit Component, I could sketch on the plywood, or I can go back to Features, and I can do things like I normally would do with a part. In this case, I'm going to do an extrude cut. It asks which face I want to cut. I'm going to cut on this face. And then I need to draw a sketch. It just moved over to the sketch toolbar. Now, here's why this is helpful. We have this circle that's here, and I'm going to try to draw a rectangle that is centered around, or a square that's centered around this circle. To do that, I'm going to start by sketching a point. That's the point. And I'm going to hover until I can make sure that this point is concentric with, or in the same place as the center of the circle that's already there. So if I click on point there, it placed a point that was in the same location as that. Okay, next, I'm going to draw a rectangle. The exact dimensions of it don't matter so right now. I'm just going to place it there, and I'm going to use the Smart Dimension tool to make it 1/8 of an inch wide and 1/8 of an inch, 1/8, 1/8 of an inch tall. And you'll notice this is not centered on that point. Now you might think that you can try to center it by using the Smart Dimension tool, Smart Dimension, and then clicking on that point. Oh, perfect. And that actually works great. I tried that a few minutes ago and it didn't work for me. But so from edge to that point, and then for this to be lined up right, I want that point to be in the middle of the rectangle, or rather the square to be moved over so that it's in the middle. And that means the point will need to be a 1/16 of an inch from the edge, 1/2 of an eighth. There we go. So that moved it over horizontally. I'm going to do the same thing by selecting the point and then selecting the rectangle and then making it a 1/16 of an inch vertically. Click check mark, exit sketch. Now it kind of looks like I sketched on the gear, but if I rotate this, you'll see that the actual sketch that I made was actually on that plane, the plane that of the block, the plane that I selected originally. I could do a blind cut if I want. I'm just going to select through all, and it's going to make that cut go through that whole block of wood. Okay, check mark. There we go. All right, now we have the location of our next dado cut. I am going to now insert. I'm going to be done with editing components. I'm going to insert another axle. Here is our 10-inch axle. This part I'm going to go through somewhat quickly since we've done a number of things like this before already. Select the face of the cylinder. Select the bottom face there. Look at it from the side. Yep, that's lined up how I want. I'm going to select the face of the cylinder again. Select either of those sides. That's not lined up how I want, so I'm going to click the Flip Mate button. Look again from the side. That looks great. All right. Now this gear is now lined up with that axle, but if you remember, think back to how I put this here. Actually, yeah, it is fixed. I was thinking that might be able to rotate. It is fixed in space, so I don't have to do anything with that. Okay, the wheel that we kind of made go away, we're going to make it show up again. We have to find where that was. Here it is. You can see it's kind of, the icon is clear. We're going to show component. There we go. Now our gear train's done. Let's go through the steps of mirroring this real quick. I also realized I forgot to center this axle. I'm going to do that. Offset distance of 2 inches. Good. Let's go through the mirroring step. We're going to create reference geometry. We're going to create a plane. We want it to be parallel to this plane, but 3 inches towards the middle. Good. Now we can mirror components. It's already selected the plane that we want. We're going to mirror that, that. Check mark. Hit save all. All right, and then you can see there is our completed assembly. Okay, a couple notes also just to end this. I decided to set up my gear train. Oh, did not copy these gears. Let's figure out why that happened. Well, oh man, and those things didn't even line up. Oh, it did. Goodness. All right, it looks like just to finish this off, it looks like since I didn't mate these, I'm going to edit. Oh gosh, can't undo. All right. I'm going to try to delete those last couple steps and see if we can fix that. Mirror component, delete. Let's go back. I think the issue that I have here is I have a few things that aren't mated that could be. So I'm going to mate that cylinder. All right, well, I'm not going to be able to solve this very quickly, but at least this side is lined up the way that we want it. I think what I should have done before I did the flipping thing was mating the inside cylinder of this gear to the axle before I did the reference geometry and flip that. At least this side is lined up the way we want. These dado cuts are lined up in such a way that these gears are going to mesh just like they're supposed to. All right, so that's it for the Sumo bot tutorials. Good job watching. Best of luck with your own design.